Okay, so let's get into this. We've got this stack of sources, quite a bit here, but um, one specific connection really jumped out, didn't it?
It did, yeah. It's this link between, well, something maybe from an old math class and a really pressing sort of real world problem.
Right. It's fascinating how these theoretical tools from one area can suddenly become so important somewhere else.
Hmm.
Your sources touch on a lot: agriculture, animal welfare. But this one insight ties the mathematical idea of differentiation
Hmm.
to heat stress analysis.
Exactly. And not just heat stress in general, the focus here is quite specific.
Yeah.
Livestock.
Livestock, okay.
Yeah, animals that are working often in post-harvest agricultural settings, places where it can get incredibly hot.
Okay, so really specific conditions,
Very specific. And this insight we're talking about, it suggests using derivatives, that core concept from calculus to model something crucial.
which is,
Not just how hot it is, but the rate, the speed at which that heat stress is actually affecting the animals in that environment.
ah, okay. So the mission then for you listening to this deep dive is to really unpack that. How can differentiation, which is all about rates of change, give us these critical dynamic insights into animal welfare under heat stress?
It's about seeing the practical power hidden in what might seem like just abstract math.
So why is the rate of change the key thing here? I mean, isn't knowing the temperature enough?
Well, that's the interesting part. If we can use differentiation to model how quickly an animal's body, its physiology, is changing because of the heat.
Like its core temperature rising
Yeah.
or how fast it's breathing.
Exactly, or even say water loss. You model that rate of change against time or maybe against some kind of environmental heat index. It gives you a whole different level of understanding.
Right. So instead of just it's 40 degrees Celsius, the animal is stressed.
Yeah, you get more. Modeling the rate tells you how quickly the stress is building up.
Okay.
So think about it, a really high positive derivative for body temperature. That tells you the animal is overheating fast.
Ah, I see. That specific rate becomes like an immediate warning sign, much more than just a single temperature reading.
Precisely. It indicates absolute danger, maybe impending collapse, much faster than just knowing the absolute temperature or a single stress marker at one point in time.
It moves beyond just measuring to, well, almost predicting dynamically.
Yes, that's a good way to put it.
Yeah.
It lets researchers or people on the ground potentially see how quickly things are getting critical, assess the speed of deterioration, understand how that stress is accumulating over time.
Hmm.
The sources suggest this kind of rate-based approach gives a much more nuanced way to analyze how the environment impacts biological systems.
So it takes that rate of change idea, maybe something you learned in the textbook,
Yeah.
and turns it into this vital metric, something you can use for monitoring, maybe even intervening
Yeah.
in a real situation affecting,
Wow.
food production and animal health.
It's a powerful example, definitely. Theory enabling very practical application.
And it really highlights how crucial these sort of foundational math tools are for tackling complex problems.
Hmm.
Problems in agriculture, environmental science, areas we see covered across all these sources you brought.
Definitely.
All right, so let's recap the core idea here. From this insight in your sources, we've seen how differentiation helps us model the rate, the actual speed, at which heat stress hits livestock in these tough post-harvest environments.
Right. It's not just if they're stressed, but how fast that stress is escalating.
And understanding that specific rate, that gives us a much more dynamic, critical insight. It lets us analyze the problem more precisely.
And that analysis, that's always the first step, isn't it? Towards figuring out, better mitigation strategies or making timely calls in the field to protect the animals.
Yeah, it really shows that abstract math isn't just for the classroom. It has really tangible, important uses out there.
Absolutely. It shows how thinking about complex systems, thinking about their rates of change, can unlock insights that just looking at static numbers would completely miss.
So here's something to think about for you listening. If differentiation can give us this level of understanding for how quickly heat stress impacts animals, what else could we analyze this way?
Yeah. What other environmental stressors, maybe changes in air quality or the spread of some kind of pathogen?
Or even other biological processes, could we understand them better, maybe even predict them? By focusing on their rates of change.
Definitely something to mull over as you encounter more complex systems out there in the world.